Welcome to the last video of Chapter 2. The last video is Section 5, Reasoning Using Properties from Algebra. We have one objective. We're going to use algebraic properties and logical arguments. What I mean by logical arguments is that we're going to do proofs. So this is something that we're going to continue in Chapters 3 and 4, but basically we're going to take a statement and we're going to try to prove something about that statement. So first thing that we need to talk about is we need to learn these algebraic properties of equality. So I'm going to zoom in a little bit. Okay, so the first one is called the addition property. If A equals B, then I can add the same number to both sides. So I have A equals B. I can add C to both sides. Has to be the same number or the same object to both sides. Subtraction property is the same. If I have some statement like A equals B, I can subtract the same number from both sides. Okay, multiplication property. You can probably guess. If I have A equals B, I can multiply both sides by the same number. Again, it has to be the same number or the same variable or the same object on both sides. And then the division property. If I have A equals B, I can divide both sides by the same number. Okay, the substitution property. This is the one that's different. So let's say I have some statement A equals B, and then I have B plus 7 equals 5. Okay, now I know that A equals B, so anywhere that I see a B, I can now substitute an A. So I can say A plus 7 equals 5. So that's the substitution property. It's just plugging in, basically. Okay, so what we're going to do now is we're going to solve an equation using reasoning, which is these properties for each step. So let's move and look at example number 1. Okay, so it says solve 2x plus 5 equals 20 minus 3x and write a reason for each step. So, first statement is going to be the equation I'm given. Okay, the reason that this is true is because it was given to me. Now I just need to think, how would I go about solving this problem? Well, I would want to get my x's alone. So the next thing that I would do is I would add 3x to both sides. This gives me 5x plus 5 equals 20. The reason that this is true is by the addition property. And it's the addition property of equality. Okay, so all I did was add to both sides. Now, I'm going to work on moving that 5 over. So I would subtract 5 from both sides. This ends up giving me 5x equals 15. Now this is true by the subtraction property of equality. Okay, so all I did was subtract 5. Last thing that I would do is I would divide both sides by 5. So this ends up being x equals 3. That's my answer. That's true by the division property of equality. Okay, so all you're doing is you're solving a problem and then you're writing reasoning for each step. Again, what's important is that in each step, when I added and I subtracted and I divided, it was always by the same number. So I added 3x to both sides. I subtracted 5 from both sides. I divided by 5 on both sides. Okay, so we're going to do a few more examples. But one more property that we have to talk about is the distributive property. So if I have A multiplied by B plus C, I can distribute the A. So that's the same as AB plus AC. You guys have seen this before, but now you know it's called the distributive property. So we're going to do another example. This one's going to involve the distributive property. I'm going to start out this problem with you, and then you're going to finish it. So we're going to start by writing our original equation. Negative 4 times 11x plus 2 equals 80. The reason is that this is given to us. Now, you could start this problem in a few different ways. I'm going to start by distributing that negative 4. So I get negative 44x minus 8 equals 80. The reason is by the distributive property. Okay, at this point, I would like you to pause the video. There's 2 more steps. I would like you to fill out the next 2 statements and the next 2 reasons. Try the best that you can, and then come back when you are finished, please. Okay, let's see how we did. Now remember that we're solving for x. So if you were solving, the next thing that you should have done is add 8 to both sides. This gives you negative 44x equals 88. The reason that this statement is true is because of the addition property of equality. So again, this reason is really what happened between steps 2 and 3. So to get from 2 to 3, I had to add. Now we would divide by negative 44. When I do that, I get x equals negative 2. So to get from statement 3 to statement 4, I had to divide. So this is going to be the division property of equality. Okay, so hopefully you got that one right. If not, that's okay. We're going to have a chance to do a few more examples in the video and then in class tomorrow. Right now, if you could please flip the page to the next problem, and we're going to go on a little bit more with these proofs. Okay, so this next problem involves a geometric figure. So it says, given that the measure of angle AOC is 130, solve for x. Okay, so the first thing that they told us is they told us that the measure of angle AOC is 130 degrees. That was given to us. Okay, so let's look in the figure. AOC is this whole angle right here. So this whole angle right here is 130 degrees. Now, the way that I can write angle AOC is I can write it as adding 2 angles together. So next, I can say that angle AOC, it's going to be x plus the 2x plus 10. So if I add my 2 little angles, I get the big angle. Now the reason for this is the angle addition postulate. Hopefully you remember this from chapter 1. The angle addition postulate told us we could add 2 angles together to get a bigger angle. Now what's really cool here is I have AOC equals 130. I have AOC equals x plus 2x plus 10. So I can now set those equal. 130 equals x plus 2x plus 10. Now, really what I did is here, instead of writing AOC, angle AOC, I wrote 130. So this is the substitution property. Okay, so my next step, on the right side of the equation, I'm going to combine x and 2x to be 3x. So I have 130 equals 3x plus 10. This reason you haven't seen before, this is just called simplifying. Instead of simplifying, you can write combining like terms. But all I did is I combined the x and the 2x and I made 3x. It's not called the addition property because I did not add a number to both sides. Okay, so now from here we would subtract 10. So I get 120 equals 3x. To get from steps 4 to 5, I had to subtract. So the reason is the subtraction property of equality. Lastly, I would divide by 3. I get x equals 40. And again, that's the division property of equality. Okay, so I know that this one is a little bit more difficult, and it's going to involve some reasons that you haven't seen before or haven't seen in a while, but that's okay. Again, we're going to do some more practice tomorrow in class. Let's move on to our next example. Example number 4. Okay, so it says when you exercise, your target heart rate should be between 50 to 70% of your maximum heart rate. Your heart rate, R, at 70% can be determined by the formula R equals 0.7 multiplied by 220 minus A, where A represents your age in years. Solve the formula for A. Write a reason for each step. Okay, so we're going to start out with the formula that we're given. So our first statement is going to be R equals 0.70 times 220 minus A. The reason is this was given to us. I'm going to do the next step with you, and then you're going to finish. So again, there's a few ways that you can solve this, but one way is you can distribute that 0.7. So I'm going to get R equals 0.7 multiplied by 220 gives me 154 minus 0.7a. Okay, now what I did is I distributed. So the reason is the distributive property. From this point, I would like you to pause the video and keep going. Now, what you need in the last statement is you need to have A equals some equation. It's not going to be a number, it's going to be an equation. So pause the video, try it on your own, and come back when you are finished, please. Okay, let's see how we did. The next thing that you should have hopefully done is subtracted that 154. You end up with R minus 154 equals negative 0.7a. Because remember, again, you're trying to isolate A. Now that is the subtraction property. So all I did is I subtracted 154 from both sides. Now, if I divide both sides by negative 0.7, on the right side they cancel, so I'm left with A equals. On the left side I get R minus 154 divided by negative 0.7, and that's the division property of equality. So hopefully that went well for you. If you made a mistake, that's okay. This isn't something that we've done in a while. But it's just getting the idea down of, this is the next step that I'm going to take, and here's the reason I can do it. Okay, we have 3 more properties to learn, and a few more proofs to do, and then you guys are finished. So, one property is called the reflexive property. This says for any real number A, this is going to be kind of obvious, that number is always equal to itself. So 7 equals 7, 3 equals 3. For the symmetric property, it says if I have 2 real numbers, A and B, if I know that A equals B, so if it's true that A equals B, then I know that B equals A. So all that's saying is if I have an equation, I can write it backwards. If I have an equation or a statement of equality, I can write the statement backwards, and it still holds true. So these may seem kind of obvious, but we are going to need to use them eventually in different steps. Okay, and then the transitive property. For real numbers A, B, and C, if A equals B and B equals C, then, okay, so A is equal to B, B is equal to C, so B is kind of our bridge. This will tell us that A equals C. So transitive property looks a little bit like substitution. But if I have 2 statements of equality and they have one side in common, so in this case B was our side in common, then the non-common sides are also equal. Quick note is this says for real numbers. When you get to advanced algebra next year, you're going to be learning something called imaginary numbers. We're not going to see that this year. All you're going to be dealing with is real numbers. But we have to write that in there because it makes the property a little bit more specific. So what we're going to do right now is we're going to flip to the next page, and we're going to do 2 more proofs that involve some of these properties. So please flip the page. Okay, so we have two more examples. These are both geometric examples. So the one on the left, it says, in the diagram, AB equals CD. Show that AC equals BD. Okay, so the first thing that I'm going to do is I'm going to write a table for my proof. On one side goes the word statements. On the other side goes reasons. Okay, the first statement is always what they give you. So in this case, they tell us that AB equals CD. And that's just given. Okay. Ultimately, I need to show that AC equals BD. So somehow I'm going to need to include AC in my proof, and I'm going to need to include BD. So I notice if I take AB and I add BC, I'm going to get AC. So right now, with the statement that I have, I'm going to add BC to both sides. So I'm going to get AB plus BC equals CD plus BC. Okay, now the reason I can do that is by the addition property of equality. Okay, so I can add the same number to both sides. So in this case, I added BC to both sides. Okay, so next I need to look at my figure and say, how does this help me? You know, why do I care? Okay, so AB plus BC. AB plus BC. In the figure, I'm going to notice that that equals AC. Okay, so AB plus BC, that's the same as AC. Let's look at the right side. CD plus BC, I'm going to notice that that gives me BD. Okay, now why is this true? Well, this goes back to the property that we used in example 3. It's from last chapter. I can add two smaller segments to make a bigger segment. So this is segment addition. It's actually the segment addition postulate. Okay, and then I have one more step. We're almost done. Going back to statement 2. So going back to this statement. Okay, now I don't really want to write AB plus BC anymore. Instead, I can put AC in its place. Then, instead of writing CD plus BC, I can put BD in its place. Okay, now the reason that I can do this is by substitution. So looking at this statement right here, any place that I write AB plus BC, I can also write AC. They're the same. Same with the statement in blue. Any place that you see CD plus BC, I can write BD. Okay, so it's okay if we're struggling a little bit. We're going to do some more of these in class. We have one more proof that we're going to do together, and then you're going to do one on your own. Okay, so this is the last one that we're going to do. It says, show that the perimeter of triangle ABC is equal to the perimeter of triangle ADC. So in this case, again, I need a table that says statements and reasons. Okay, so there's no information that we're given right off the bat in this upward, these directions at the top. But instead, we're given information in the diagram. So one thing that we know is we know that AD is congruent to BC because of this single tick mark. We also know that DC is congruent to AB by the two tick marks. So the reason for this is both of these statements are given in the diagram. Okay, so that's what we know right off the bat. I need to think, what am I trying to prove? I'm trying to prove that the perimeters are equal. Okay, so what does perimeter mean? Perimeter means that I add up all the sides. So far, I have this triangle right here that I'm looking at, and I have this triangle right here. In my proof, I've mentioned 2 of the 3 sides of both triangles. The only side that I have not talked about in my proof at all is this side right here. Now, both triangles share that side. So that's my next statement. I know that AC is congruent to AC. So this is a reason we haven't used before. Any object is always equal or always congruent to itself. That's called the reflexive property. Okay, any object is always equal to itself, so that's what we did on the previous page. Now, I have all the sides of one triangle, and I have all the sides of the other triangle. So if I look at AD plus DC plus AC, AD plus DC plus AC, that's one triangle. So that's in blue. Then the sides that are circled in red are this triangle right here. So now I can say that the perimeter of triangle ABC is equal to the perimeter of triangle ADC. The reason is all the sides are congruent. And I'm going to say that's proven above. Okay, so this is tricky. I know that this is tricky. And it's only one section. In the next chapter, we're going to do a lot more proofs and have a lot more practice. So just try to stick with me. If you have any questions, please make sure that you put a star or you write down your question so that you remember to ask me tomorrow. We're going to return to what our objectives were. So, what did we want to accomplish? Well, we wanted to use algebraic properties in logical arguments. So this is the problem that you're going to do. I'm going to start you out. Solve and write a reason for each step. So you should have 8x minus 5 equals negative 2x minus 15. And the reason is that this is given. Okay, so you need to go step by step, write each step and a reason for each step. When you come to class tomorrow, I'm going to be checking to make sure that you have this problem completed. If you do, you will receive credit for the video. If you don't have the problem completed, you will not receive credit for the video. If you need help, please make sure you go back to problems 1 and 2. Good luck!